Here's a problem that requires a lot of drawing. So here we're trying to find the exact value of cosine of alpha minus beta. And it's given that the sine of alpha is equal to negative 2/3. In other words, the sine of the angle's ratio is negative 2/3. And this angle happens to be in quadrant 4. They have to give you these two pieces of information because the sine can be negative in two quadrants. Remember, this is all students take calculus. So that means that sine is negative in the third and fourth quadrants. Therefore, this one nails it down into the fourth quadrant. We want this to be in only one quadrant. Therefore, we can find the answer to this. And the same thing for tangent of beta here. It's positive 1/4, and it says it's in quadrant 3. The tangent, remember, is positive in 1 and 3. So what I'm going to do is set up two pictures here. This is going to be the alpha picture, and this one over here is going to be the beta picture. So the alpha picture is going to be a sine with this ratio in the fourth quadrant. So the first thing I'm going to do is draw an angle in the fourth quadrant. So I'll, draw a side going this way and draw a side going that way. Oops. So my triangle that I want to look at is down there. For the beta picture, which is in the third quadrant, I want to draw my picture here. Now, it doesn't matter if the picture is perfect. So here we're talking about the sine of alpha is equal to negative 2/3 in the fourth quadrant, and therefore this is the reference angle, and the sine is equal to opposite over hypotenuse. So this side is going to be 2, and this side is going to be 3. And I'm of the habit of putting the negative where it belongs, because this side is going down, it's going to get the negative 2. So what I need to do is find what the length of the third side is, and that's going to require Pythagorean Theorem. C squared equals a squared plus b squared. I like writing it this way to concentrate on the hypotenuse first. Oops. So the hypotenuse here is 3, so this is going to become 3 squared, better known as 9. And whether you put the negative 2 in the a and b is irrelevant, but when I take negative 2 and square it, it's going to give me a positive 4 plus b squared. So the unknown side here is this b side. So this is going to become 9 minus 4 is equal to b squared. Therefore, b is going to equal the square root of 5 after you subtract and square root both sides. Now it's plus or minus the square root of 5, but because it's going to the right, I'm just going to put in the square root of 5. All right, so let's work on the other triangle here. Tangent of beta is equal to 1/4. The reference angle is here, and tangent is equal to opposite the angle, adjacent to the angle. So this side is 1, and this side is 4. Now because it's going to the left and down, they're both negative. And a negative divided by a negative gives us this nice positive tangent. Again, we need to find that third side, so c squared equals a squared plus b squared. In this case, I don't know what the hypotenuse is. Remember, it's the side opposite the right angle. It's unknown. If I square 4 and 1, I'm going to get 16 and 1. So c is equal to the square root of 17, plus or minus, but because it's the hypotenuse, it has to be positive. So square root of 17. All right, so now that I have my pictures all marked up, I can go and look for the main part of this question. What is the cosine of alpha minus beta? So the formula for cosine of alpha minus beta, and the cosine pattern is cosine of the first, cosine of the second. Oops. If it's minus on the inside, it's plus on the outside. Sine of the first, sine of the second. And we get that set up. Back to green. So cosine of alpha. So the cosine of alpha is this picture. We're looking at this reference angle, and cosine is adjacent over hypotenuse. So this will be replaced with the square root of 5 over 3. All right, next up is cosine of beta. And the cosine of beta is working with this angle. And again, cosine is adjacent over hypotenuse. So this would be -4 over the square root of 17. Plus, all right, sine of alpha, back to the other picture, back to this angle, and the sine is equal to opposite over hypotenuse. So this will be -2 over 3, exactly the way they told us what the sine of alpha was, which is fine. And then for beta, we're back to the purple picture here, and the sine of beta is going to be opposite over hypotenuse, -1 over square root of 17. Now this isn't very pretty, but we should be able to get it looking somewhat nice. Now it's your choice. You can rationalize this fraction and write it as -4 square root of 17 over 17. It'd probably be the safest to do it that way, but not super necessary because we can type all this into a calculator and come up with a nice decimal form. So I'm going to leave it alone. This becomes -4 square root of 5. Negative times a negative is a positive. 2 over 3 square roots of 17. So if you want to play around, you can sit here and multiply top and bottom by the square root of 17 to rationalize the denominator and come up with a horrible -4 square roots of 17 times 5. 85. So this would be the square root of 85 plus 2 square roots of 17 all over 3 times 17, 51. And this would be the rationalized answer of cosine of alpha minus beta.